You ever get that feeling that your phone just gets you? You know, like there's some kind of secret language it's speaking, a hidden blueprint that connects every single thing you do online? Well, guess what? There is. And today, we're going to pull back the curtain and see exactly what it is.
Just think about it for a second. What on earth is the connection between your GPS finding the absolute fastest way to work, your social media feed digging up a friend you haven't seen in a decade, and that shopping website knowing with spooky accuracy exactly what you want to buy next? It feels like magic, right? But it's really not.
So let's start with something we all use every day, your GPS. It takes this insanely complex web of streets, traffic lights, and current traffic jams, and somehow, in less than a second, it spits out the single best path to get you home.
Then you've got your social network. It's constantly sifting through literally millions of people. It finds someone who happens to know your college roommate's cousin, and bam, a new friend suggestion pops up.
And of course, there's the online store. You buy one thing, say a new video game console, and all of a sudden it's recommending the perfect game to go with it, a better TV to play it on, even a tablet. I mean, how does it know all those things are connected?
Well, here's the secret. All of these incredibly different, incredibly complex systems, they are all built on the exact same, surprisingly simple underlying idea. A single blueprint that organizes all of this chaos.
And that blueprint is something called a graph. It's a way of seeing the world not as this messy, complicated jumble of details, but as a simple, elegant collection of, well, dots and lines. Okay, so the official textbook definition is that a graph is a data structure for representing connections among items and consists of vertices connected by edges. I know, that sounds a little dry and academic, but the idea behind it is about as simple as it gets. It really just boils down to two key ingredients. First, you have vertices. Those are just the items, the dots. A vertex could be a city on a map, a person on a social network, or a product in a store. And then you have edges. Those are the connections, the lines that link the dots together. And that's it. Seriously. This ridiculously simple concept of just dots and lines is the secret engine powering so much of our digital world.
And this is where the real power comes in. It's a concept called abstraction. We can take something messy and complicated, like this physical computer network, and just simplify it. Each computer becomes a dot, a vertex. Each cable hooking them together becomes a line, an edge. And just like that, this tangled system becomes a clean, simple map that a computer can easily understand and work with. It's the exact same principle for streets, people, and products.
Okay, so it's cool that we can make these maps of connections. But just having the map isn't enough, right? The real magic is using these maps to find the smartest, most efficient way to get from one dot to another.
So, how do we find the best route? Well, first off, any route from a starting dot to an ending dot is just called a path. You could take a super long, scenic path if you wanted to, but what we usually care about is the shortest path, the one with the fewest lines or edges. And in the world of graphs, that's what we call the distance.
So, if we go back to that computer network, the shortest path from PC1 to PC2 might be just 2 hops. Its distance is 2. It's the most direct route you can take. Simple as that.
But hang on, because this is where it gets really clever. The shortest path isn't always the best path. Think about it. Taking the route with the fewest turns doesn't help much if one of those roads is a total parking lot because of traffic, right?
And the solution for that is to add weights to our lines. So now, an edge doesn't just represent a connection, it can represent things like travel time, or cost, or even the actual physical distance. So your GPS isn't just looking for the path with the fewest streets, it's adding up the travel time on each street to find the path with the lowest total time. And that's how it outsmarts traffic jams for you.
All right, so we can find the best path between two known points. But what about finding totally new things? How do apps explore these enormous webs of connections to suggest something you've never even seen before?
Well, for that, there's a really smart method called breadth first search, or you'll often hear it called BFS. The idea is actually pretty intuitive. You start at one point, and then you explore outwards in layers. You check out all your immediate neighbors first. Then you check out all of their neighbors, and so on, one layer at a time.
Let's make this totally concrete. Here's a little social network. We're going to start with this person, Taj, and we're going to use breadth first search to explore his network and see if we can find anyone he might know but isn't friends with yet.
It works just like dropping a stone in a pond. The first ripple goes out and hits all of Taj's direct friends, the people who are at a distance of 1. So that's Joe, Chen, and Lily. The algorithm has now visited them.
Then, the next ripple spreads out. The algorithm moves to the next layer and finds the friends of his friends, all the people at distance too. And in this layer, we discover Eva and June.
And here it is, the aha moment. The breadth-first search found people, Eva and June, who are definitely connected to Taj, but not directly. They are friends of his friends. And that, right there, is how your social network generates those people you may know suggestions. It's not some weird black magic. It's just the computer exploring the graph, one ripple at a time.
So once you start to see the world in terms of these graphs, of these dots and lines, you begin to realize that this so-called hidden blueprint isn't just in a few apps. It is, quite literally, everywhere you look.
I mean, think about it. This simple, powerful model is the engine behind geographic navigation, product recommendations, and all our social networks. But it doesn't stop there. It also powers things like peer-to-peer file sharing, helping your computer find the fastest person to download a file from. It's behind so many systems we rely on every single day. It truly is the universal language of connection in our digital age.
And you know, in the end, it all comes back to this one simple, fundamental truth. Many items in the world are connected, and a graph is simply the best tool we've come up with for representing all those connections. It's just an elegant and incredibly powerful way to model the complex relationships that make up our world.
So all of this leaves us with one last really fascinating question to think about. If this simple blueprint of dots and lines can be used to map and understand almost any connected system, what do you think we should map next?